Felicitate our chief guest Rangarathnam Gopu sir. எண்ணென்ப ஏனை எழுத்தென்ப இவ்விரண்டும் கண்ணென்ப வாழும் உயிருக்கு. நல்லவர்க்கு அறிவியலும் கலையியலும் சிறந்த கண்கள் என்று அறிந்தவர் கூறுவர். இதற்கு உதாரணமாக வானவியல், கணிதவியல், அறிவியல் உண்மைகளை பாரம்பரியமும் பழமையும் கொண்ட நம் இந்திய அறிதல் முறைகளோடு தொடர்பு படுத்துவதில் தனித்துவம் மிக்கவர் இந்நிகழ்வின் சிறப்பு அழைப்பாளர். Good morning, respected dignitaries and everyone present here. It is my great honor to welcome our esteemed speaker, Mr. Rangarathnam Gopu sir, Varahamihira Science Forum, who has graciously joined today. Rangarathnam Gopu sir is primarily known for his work in promoting scientific thought and dialogue, particularly through association with the Varahamihira Science Forum. Sir's contribution can be categorized as promotion of scientific literacy, his work on spreading scientific knowledge and encouraging people, especially in community or region, to adopt a scientific mindset. It involves organizing seminars, talks and workshops to discuss various topics. Sir also discussed about the different branches of science such as physics, astronomy, mathematics to solve complex problems. Sir's talks often revolve around the importance of science in everyday life, bridging ancient Indian knowledge with modern scientific advancement and fostering critical thinking. Exploring the contributions of ancient scholars like Varahamihira and how their discoveries align with or influence contemporary thinking. Academically, Gopu sir studied computer science at Texas A&M University and computer engineering at Arulmigu Kalasalingam College of Engineering. Sir has also contributed to the Center of Indic Studies at Indus University, offering courses such as Indian mathematics and astronomy. We are looking forward for your knowledgeable input, sir. The stage is yours.
Okay?
Yes, sir.
கொஞ்சம் நோத்திக்கலாமா ஃப்ரண்ட்ல ரொம்ப வேணாம். ஐ திங்க் அட் திஸ் ஆங்கிள் இட் பி ஓகே. சரி இல்லை இது போகிறோம். ஐ திங்க் ஐ கேன் சி ஃப்ரம் ஹியர். நான் நெக்ஸ்ட்னு சொன்னால் நம்ம ஸ்லைட் மாற்றேன். ஓகே. ஸோ வணக்கம், நமஸ்காரம், குட் மார்னிங். Thank you all for being here. Thank you to the TG Vaishnav College and especially Professor Uttaradhara Rajan for inviting me to give this talk. I'm delighted to be at this. It's okay. Delighted to be invited to this talk. I've had the pleasure of addressing this college a couple of times last year and earlier, and attending several other seminars even before that. So I'm looking forward to this slightly unusual talk. It's kind of a historical, historical exploration into this particular topic. This is actually not very popularly explored. So, it's kind of a long type topic, right? Sphericity and its astronomical and mathematical consequences. By sphericity, I mean the sphericity of the Earth. We just take it for granted today that Earth is a sphere, all planets are spheres, Sun is a sphere. That was not always the knowledge. Can we go to next slide, please? And today in astronomy, we have only one mindset of astronomy. Astronomy started with telescope and perhaps with heliocentric theory. Actually, telescope as an astronomical device came in after Copernicus proposed the heliocentric theory. So he discovered this without the telescope. But in our mindset, even more than heliocentric theory, telescope is, if we say astronomy, the first thing people think of is telescope. Correct? You don't need a telescope to do simple astronomy. Next, please. In fact, astronomy has been a field of study for 4,000 years. 4,000 years where? In India, Egypt, China, and ancient Sumeria. Sumeria is today the country we call Iraq, right? Mostly Iraq. So these four old cultures have explored some degree of astronomy. It may not all have latest galaxies and black holes and all these theories, quantum physics and all that, but some degree of astronomy has been conducted for 4,000 years in these cultures. Next, please. I'm saying at least 4,000 years, maybe older. We know for about 4,000 years it has been happening. And this is even another interesting point. We've had several discoveries in astronomy. Our perception of the universe, of the solar system, of what astronomy is, has changed. Every century, perhaps even every 30, 40 years, some very interesting paradigm shift has happened. So for 400 years, there are several tools and several conceptual differentiations or novelties after the telescope. But still, I think astronomy telescope. This is like a trigger factor, right? It's like democracy elections, right? That's the only thing we first associate with it. And that's not necessarily the case. That's my point. Next, please. So, what has been invented? What are the tools of astronomy? Take a quick guess before you go. Can you say what is relevant to astronomy after the telescope, which is about 400 years old? Galileo first used telescope. Telescope is older, but Galileo used, we all know, the telescope to look at the moon, the sun, Jupiter, etc. What do you think as a conceptual idea or as tools are useful for astronomy? Can you guess? We changed our idea or modified our idea of astronomy. Any device or technique or even field of science? Anybody guesses? I'm really asking you. I have two, full screen full of things I'm going to come up with. And once I come up with, you'll agree. But before that, I'm asking. Not even guessing. You're just scared of being embarrassed. Anything. Device, technique, concept, whatever. Parallax method, okay? That's actually much older. Believe it or not, that's actually much older than the telescope. Yeah. Anything else? Anything related to physics or any science that influence astronomy? You don't think of it as astronomy related, but it very, very dramatically influenced astronomy. That is my point. Kepler was before this, but okay. But I'm not asking like that. I'm talking of even a tool. I'm talking of even an idea. Anything else? This is fine. Is it? I'm clearly audible, right? Can you hear me at the back? Okay. Anything else? See, this is the thing. You're boxed in. You're thinking of certain. There are other developments in physics, for example, that you think of as physics development, but not astronomy, but it phenomenally influenced astronomy. So let me ask a question. What is the sun made of? Hydrogen. So when Galileo and Newton came up with it, did they know there is something called hydrogen or helium? Who discovered that? Who discovered hydrogen? Very simple. What field do you think hydrogen comes under? Physics or? So chemistry as a field came 200 years after. 1789, 1770, 75, 78. That's when they discovered, this fire, air, water concept. 4 elements. That was, Newton thought 4 elements. Newton was tinkling around. Newton was terrible at chemistry. He was doing alchemical experiments. Harry Potter and the Philosopher's Stone. Newton was trying to make a Philosopher's Stone. You know what Newton said about electricity? Or thermodynamics? Steam engine? Absolutely nothing. He didn't know, even though they were there in his time, he did not even touch these fields. Can you imagine? I'll ask an equally, what did Einstein say about biology? As little as possible. He stayed away from it. Okay? But would you accept that today? The scientist, the physicist, the greatest physicist perhaps of the 20th century has zero interest in biology. That's how it was. Imagine Newton said nothing about electricity, nothing about thermodynamics, and nothing about steam engine. That's mind-boggling. If you did that today, you would be considered ignorant. If you are a physics student, you didn't know the difference between vertebrata and invertebrata, even though you are a physics student, you will be considered ignorant. Newton didn't know anything about hydrogen or helium. Galileo didn't know anything about hydrogen. But you see, understand what I'm saying? Chemistry, modern chemistry with elements and hydrogen and combustion is 200 years after Newton and Galileo. We cannot think on what else. Is the sun burning? Is hydrogen burning in the sun? Is hydrogen burning in the sun? Is it a chemical fire? Is it oxygenation? Do we get water from it? What is it happening? What's happening there? Fusion, right? When did that idea come along? We think it was a physics idea from the time of Einstein saying E equal to mc squared and that Bohr's atomic model, right? And radiation, all of these concepts, Ernest Rutherford coming up with alpha rays and gamma. Suddenly you're studying Curie. So 1900 and later, you're getting what is called an electron and a proton, atomic model, Bohr's model, E equal to mc squared, that the sun is not a chemical fire but a nuclear fire. This is all astronomy. This affects astronomy, but you don't think of it. Right? So what is that? What comes from the sun? Name one type or two types? Heat. Heat and what is light? Electromagnetic physics, no? You always say electromagnetic radiation. Correct. When did electromagnetism come along? Was it known before? To get electromagnetism, what did you know before that? You had to study something called electricity and something called magnetism. That's what I'm talking about. Go ahead, please. Invented after the telescope from 1600 to 1900, you had, please go through them one by one, calculus, which Newton invented, gravity, which Newton proposed, but it is not the original. He was trying to overthrow the idea of Descartes. So optics, then laws of motion, then Cartesian geometry. Not geometry with the Euclidean style, but putting x-axis, y-axis and putting slope and all that stuff. Then electricity, electromagnetism, chemistry, spectral lines. If you look at astronomy in the 19th century, that is from around the time of Lavoisier and Priestley when they discovered oxygen, nitrogen, etc. Bunsen and all that. You remember those chemicals? They learned, discovered that if you put a fire and put something, if you burn sodium, potassium, etc. All of this were identified only after Lavoisier, after 1774, 1775, when chemistry became a proper modern science. Then they discovered that different elements give out different things that you can identify with spectral lines using a spectrometer. Right? You use a prism, you use something, suddenly sodium is giving a line, potassium is giving a line, hydrogen is giving a different line. So 19th century astronomy was only spectroscopy. There was nothing new in terms of, there is not fantastic advancements in terms of telescopes. Okay, but fantastic advancements in terms of chemistry. So the stars, this star has hydrogen, this star has sodium, this star has all this understanding of different chemicals coming from the stars, the signature of the stars coming from there. Chemistry was a vitally important tool, not just being chemistry, not just being spectral lines on organic or inorganic chemistry, but stellar astronomy was phenomenally influenced by this. Understanding that light is an electromagnetic wave, to understand that you need electricity and magnetism, to understand that you are coming up with calculus and Hamiltonians and all that stuff. Those of you who have studied Maxwell know that Maxwell didn't come up with the form of the equations that he did today. We have 4 Maxwell's equations today in physics. He didn't come up with that. He came up with 20 equations using some quaternions and some terrible mathematics that we don't study, or the rest of us don't study. You may study. I don't know. Somebody called Oliver Heaviside fixed them and said, put all this into differential calculus and partial differential. That was Heaviside's equations. But he was so modest, he continued to call them Maxwell's equations. Next, please. What about 1900 to 2020? Electrons, protons, the things I'm talking about. Bohr model. Next, please. Atomic physics, radio, X-rays, space-time, relativity, E equals mc squared, galaxies, Big Bang theory, gravitational waves. All of these are astronomically related. The first 5 or 6 you think only as nuclear physics or atomic physics, but they are dramatically emphasized because Kelvin, Lord Kelvin, the one after whom Kelvin scale is named, the great genius of thermodynamics, electricity and all that, he refuted, what he refuted? He refuted Darwin's theory of evolution. He said Darwin is saying, world is 500 million years old, some plants and animals, Cretaceous period. The world cannot be more than 300 million years old. Why? Because sun is made of hydrogen and helium, chemical fire, it cannot, that mass that we calculated at chemical, because he didn't know anything about nuclear fusion or fission. The sun can be only 300 million years old. How can the earth be older than the sun? No. So Darwin's theory is wrong. Physics supposition. With the physics he knew he was right, but the physics you know was inadequate. That Kelvin knew was inadequate. Just like the physics that Newton knew was inadequate. And how much of this inadequate we don't know. What happens if everything gets thrown away? What if all of this is wrong? Okay. So there is so much in astronomy, but we are obsessed with telescope. That was my point. We think of heliocentric theory and telescope as the foundations of the dramatic revolution. But now I am going to go to an older thing. The point where they discovered that the earth was a sphere, and this is an understanding nothing to do with Columbus. Long before Columbus, some people Columbus wanted to prove the earth. Nothing. He knew that the earth was round. All the scientists knew the earth was round. General public don't care about this stuff. Even today, sun is a nuclear fusion, blah blah blah. We are still celebrating Pongal and doing, Padayal for sun, no? Right? Surya Namaskaram and all that stuff. We take that as two different things. You don't say you are worshipping nuclear reactor. No, don't. Nobody's saying that. Right? You can say this, you'll just get laughed out. Okay, next. So the history of astronomy is different in different countries until we get to the globalization with, not because of the scientific revolution of those people, but because of East India Company. East India Company conquered India. Segments of them captured Africa. They captured parts of, East India Company's explorers, and then English people captured Canada, Australia. The French then started their East India Companies, the Dutch East India Companies. 5 East India Companies, all coming for what? They were all coming for cotton. Columbus went to America because he was trying to become a trader with India. He was trying to find the route to India only. That's why he called it East Indies, West Indies and all that stuff, right? He was looking for India. They called the people they're Indians because he was mistaken. They're trying to mainly buy spices and cotton, right? That globalization happened, and when that period it happened with the telescope, with the gravitational theory and advances in mathematics and laws of motion and all that, we then started having their system. The European system became the global system and eradicated all the independent styles of astronomy the other cultures had. Chinese had their own astronomy, Indians had their astronomy, there are some exchanges here and there. The Arabs had their astronomy. The Egyptians are dead because the Egyptian culture was dead and replaced first by the Greeks, then by the Christians, then by Islam, and it stayed like Islam until the 19th century when British knowledge systems basically started worldwide. Sumerians, even more complicated story, I won't even go into it. Okay? But if you look at Indian astronomy, there was a corpus of knowledge during the Vedic period where there was no specific book. Then there was one particular period that is calculated to be 1400 BC based on an observation. There are 2 books called Rig Vedanga Jyotisha and Yajur Vedanga Jyotisha. These are the oldest books in astronomy. The 2 oldest books in Indian astronomy are called Rig Vedanga Jyotisha and Yajur Vedanga Jyotisha, and they are written by the same person. Do you know who it is? Absolutely no Indian knows this. Why? We can name 7 Europeans. Pythagoras, we'll say Euclid, we'll say Eratosthenes, we'll say Archimedes, we'll say all these names. No Indian science student ever cares that it may be wrong, it may be outdated, but some person wrote one astronomy book long ago. Who was it? Only person we know is Aryabhatta. Some people know Bhaskara. 2 people and then we are done. Then we come directly to C.V. Raman and Chandrasekhar. Nobody. 4,000 years, nobody else was there. What did Aryabhatta do? He discovered zero, which is wrong. Aryabhatta, zero was already 1,000 years old when Aryabhatta was born. So we are proudly ignorant of our own system of education, system of astronomy, science, maths, everything. Right? So a person called Lagada is a rishi called Lagada. That Lagada wrote those 2 books. Those 2 books seem to have been the astronomical standard for a while. Around, and I'm saying 500 BC, but I'm not sure at all about this number. And I'm saying 500 AD, which I'm much more sure about. Because 500 AD is the date of Aryabhatta's book. 499 is the calculated date of Aryabhatta's book. From Aryabhatta, you see a dramatic transition in the Indian astronomy and mathematics. Not because he did several new things in astronomy, he didn't. All the revolutions happened earlier in the Siddhanta period. Those Siddhantas are attributed to people called rishis. Okay? Aryabhatta and others are not considered rishis. Aryabhatta, Varahamihira, Brahmagupta, Bhaskara, Madhava, these people are not considered rishis. They are simply considered Jyotishas or Ganakas. That is, astronomers or mathematicians, they are considered the same profession. Okay, but the people before them are called rishis. People like Brahma, Vashishta, Parashara. Okay, those people are all rishis. And there came the Rishi Siddhantas. Next, please. And this Rishi Siddhantas had all these rishis. Surya, Pitamaha. Pitamaha is another name for Brahma. Okay, Vyasa, Vashishta, Atri, Parashara, Kashyapa, Narada. All these 18 Siddhantas are supposed to have been there, but last of these books are lost. Only Surya Siddhanta remains in somewhat full form. 4 or 5 of these are remaining in some reference form in Varahamihira's book Panchasiddhantika. He compares 5 books of astronomy. So we have some references of 4 of those. Next, please. But this period of the Rishi Siddhantas, before Aryabhatta's book we have in complete. Fully complete form we have. We have commentaries on it from the 6th century until the 19th century. People have commented on Aryabhatta. Okay. The period of those 18 Rishi Siddhantas was important, it was transformational, but it is also enigmatic, it's puzzling. It was transformational because astronomy became very mathematical at that point. Before that, they didn't really use geometry. In Lagada's book, there is very little geometry. There is no trigonometry, there is very basic algebra. And we don't know if it is a proper spherical model or not. Okay. Geometry became fundamental to astronomy in this period. Trigonometry with the sign. The sign is an Indian invention. Nobody tells you this. The sign that we study today is Indian invention. We don't know who invented it. Okay, we don't know who invented it. Aryabhatta uses it, but we don't know who invented it. Before Aryabhatta, it was in use. Okay, just like zero, sign and its trigonometry is a bad name for it. I'll tell you why. And new concepts are introduced in the calendar, dramatic changes happened. It was enigmatic or mysterious because all those books are lost. We have references to it in other slokas that this book was there, that book was there. All the books except Surya Siddhanta are lost. And Surya Siddhanta as we have today has been modified since then. There are some Bhaskara's concepts in Surya Siddhanta. What does it mean? 700, 800 years later, somebody put something in Surya Siddhanta because their addition in the family, they modified it. Suppose you had Silapadikaram and you are a big fan of Vairamuthu and you put Vairamuthu's song in Silapadikaram. It's no longer the original Silapadikaram. Or if you put Kannadasan's song, it's no longer the original Silapadikaram. Right? This kind of thing, all our books have had. It's called interpolation. Over times, what happens? There's a book that's been passed on from century to century. It is copied because old form, palm leaf will be deteriorate, something like that, or oral tradition. When somebody modifies it, it's called an interpolation. We have an interpolated Surya Siddhanta, but we have some older concepts also there. Okay, so kind of hard to separate the two. So this is the problem. Historians, it's a nightmare because we don't know we have to guess at which is the original, which is the interpolated version. Next, please. So what happened in this period was the great introduction of the spherical model. Very clearly, they understand that the Earth is a sphere. there is no tremendous argument saying, no, we used to think the earth was flat, now we think the earth is sphere. Nobody is doing that argument at all. If that argument was made, that record is not there. Okay? It's in fact not there even in the other cultures. But they started using spherical astronomy. Sphere is important because why? We have a concept of equator. You only have that if it is a sphere. You have a concept of longitudes and latitudes. Right? Meridian, prime meridian. What is the prime meridian today? If you use a global meridian, what is the meridian used today? Greenwich. It's 150 years old. Indians are using Ujjain meridian for 2000 years. How many of you have heard of Ujjain meridian? Please raise your hand. Why don't we know that we have been using a prime meridian for 2000 years, but we only know the meridian we are using for 150 years? The Greeks, Ptolemy used Alexandria, not in Greece, but in Egypt. They used Alexandria meridian. Have you heard of Alexandria meridian? What kind of education do we have? If physics people don't know that there was an Alexandria meridian and Ujjain meridian, okay. So, but what happened here? That understanding that the earth was a sphere, utilization of earth as a spherical concept, and therefore space also is a spherical concept. We know the word Bhu-Gola, right? Everybody knows the word Bhu-Gola. Bhu is earth, Gola is sphere. Goli, marble. Play Goli is sphere, Gola is sphere. Right? So Bhu-Gola, we not only have Bhu-Gola, we have Khagola and Bhagola, which we'll come to. So because of that earth as a sphere, then we have latitudes and longitudes. Then we can draw lines in space parallel to those longitudes. Those are called celestial longitudes and celestial latitudes. In astronomy today, they are called declination and right ascension. You know, some of you studied astronomy knows. Okay? Geometry. Now, actually, I think in physics, you don't have a separate astronomy paper. Do you have it? Undergraduate physics, you don't. Master's physics, you have to go. It will be an elective subject. Astronomy was the only physics for 2000 years until 16th century, 17th century or so. Then optics, kinetics, dynamics, all this came in. Then thermodynamics, electricity and all that came in. Then atomic physics. Now what has happened? Astronomy has gone out of physics. Except at the PhD level. What a sad story that is. Okay. Then we introduced geometry with angles, circles, spheres. We didn't use it for drawing circles in the ground floors also. We used that also. But it became much more advanced in India. New astronomy came in with Khagola, Bhagola, which I'll explain. And only when you have the concept of Earth as a sphere, Moon as a sphere, Sun as a sphere, you will understand that eclipses are made by shadows, not by Rahu, Ketu, etc. In fact, in Vedas, the original representation, the eclipses are not made by Rahu, Ketu. You know this Rahu, Ketu story, right? One snake comes and eats moon, what comes and eats tongue, and then it spits it out, and then that story. In the Vedas, that is not the story. It's a different story told. There's an Asura called Swarbhanu, and he blocks the sun. And a Rishi called Atri chants a mantra. That story is gone. Suddenly Rahu Ketu comes. We don't know where Rahu Ketu comes from. It comes from one of the Puranas. Okay. Then you have the understanding of motion of planets. Jupiter, Mars, Mercury, everything is going in orbits. Only if you think of the Earth as a sphere, then the orbits make sense. Okay. You have epicycle, you have predictions of eclipses, you have adoptions of Rashi, the discovery. Parallelly, in this period, unrelated to this sphere model, Indians came up with the place value system, which is separate from zero. Okay, but it is very, very closely related to the zero. Understand what I'm saying? Place value is separate from zero. You can have zero without place value or place value without zero, but the combination is a fantastic combination. You have both together. You have completely breathtaking mathematics. And then from there you have advances in arithmetic, advances in algebra. Indians were the dominant superpower of algebra for 1000 years. But algebra has an Arabic name. We called it Avyakta Ganita and later called Bija Ganita. Now this went into Baghdad, it became called algebra. From algebra, there it went to England, Europe and all that. It became stuck as algebra. And now we are studying it as algebra without studying the original name, Bija Ganita. Same with sine. Sine was called Ja. It went like this, and now we are studying like this. Ja is sign. Okay, and then the development of angular instruments, because you need to do study all of that, and then this thing. Next, please. You adopted solar months, etc. So the consequences of spherical geometry is what I'm going to talk about. Next, please. So I'll rush through some of it. To understand what that is, you have to understand what was the pre-spherical spherical geometry idea. Okay, one was the concept of the earth with a huge mountain in the center called Meru. Okay, and they thought that the sun went around Meru in the evening. It rose from one side of the Meru, behind the Meru, and it came in the, so that was daytime, and then evening it went to behind the Meru and it disappeared. So we had night time, and the moon came along. Now, the moon has nothing to do with the sun, by the way. The moon moves at a different speed besides the sun, but that's what they thought. Okay, and then they thought, they gave the example of a lotus flower. It's a metaphor, it's not an actual physical model. That there is, think of it as a big, beautiful lotus flower, the central stalks being Meru, and then 4 petals on 4 sides. And these are the 4 petals are called the 4 continents. Kuru, Uttara Kuru, north of Meru. Himalayas are south of this Meru also. Okay, Kuru is north of Meru, we can't even see it. And then Bhadrashva to the east, Bharata to the south, Bharadakandam. You heard the word Bharadakandam? That what Bharadakandam is, it's one of the 4 continents on the 4 sides of the Meru. And left or west, you have Ketumala. Today, that would be the American continent. But that's not what they thought of. That's not their visualization. Not, we can't, equivalent. But that they had a flat, they seem to have a flat earth model with the Meru in the middle. At the top of the Meru was the Devaloka, where all the Devas resided. This Meru was a very gigantic mountain. Okay, it's not a simple mountain like this, it's a mountain like this. The base is narrow, the top is broad, and that's where the Devas resided. At the bottom, flat earth, below the earth, at the opposite equivalent was Narakaloka or Vadavamukha, where the Asuras resided. Devaloka or Swarga, Narakaloka are where the Asuras resided. So this is the concept that they had. Next, please. From that view to understanding Earth as a sphere was a transition, but there is no explicit mention of it. They just assume. It's completely suddenly redefined. Meru is now redefined as North Pole of the spherical Earth. Vadavamukha is redefined as the South Pole of the spherical Earth. This is in Indian astronomy. What Chinese did, Egyptians did, I don't know. Okay, we know what the Greeks did, and there are also some missing stuff there. Because the Greeks thought, this equivalent of the Greeks for this was the mount called Olympus, where they held at the base of the Olympus mountain, what did they have? The sports contest, which was revived in 1900. International sports contest. Olympics. Olympus was their Meru. Okay, they thought Devas lived there. Their gods are Devas. Now you are seeing it, Zeus and all. Now the Avengers and all these things have made it famous. Your children are reading Percy Jackson or whatever. Titans are the Asuras. Gods are the Zeus and all these people are the Devas. So they thought that. And so they also transitioned, and we don't have that information because all the Greek books are gone. The oldest Greek book we have is from 12th century AD. All the old Greek books are gone. But they tell you as though all the Greek books are still there in original condition. Okay. How can humans or trees? Now here's the problem. If you have a spherical model of the earth, spheres like this, ordinary person will ask, what will ask? It's a flat place like this, I can stand on top. If this platform that I'm standing on is a sphere, if I'm a very gymnastically talented person, I can stand at the center. Otherwise, I'll be toppling and falling off. And they did not discover what this Newton's law of gravity, 2 things attract each other, is there. So how are people standing on the opposite side? How can people be there on the other side, this side, that side, anywhere side? Okay, even the Greeks talked about it. He said, everybody in Greece asks, how can people stand on the other side? Not thinking that you may be on the other side. For that person on that other side, you may be on the other side if it's a sphere. How do you deal with it? Next, please. Most of them didn't deal with it, but Varaha Migura gives a metaphorical explanation. He says, Panchamaha Bhutamaya Stara Gadapachare Mahi Golaha Kayas Kantantasto Lohaiva Vastito Vrittaha. This is explanation. It's a metaphorical explanation. What does it mean? He says, Panchamahabhutam ayas. Panchamata Mahabhutam, 5 elements. He said the earth is made of 5 elements because Lavoisier had not done these experiments, no modern periodic table yet. So they thought the world was made of these 5 elements. This, the last word you see, Gola is sphere. Mahi means earth. Earth is a sphere. He's saying, earth is a sphere made of these 5 elements. It is suspended among the Tara Gana Panchare. Tara means star, Gana means number of stars, count of heap of stars. Panchara means cage, like a bird cage. What do you have a bird cage? You will have a big bird cage with lines like longitudes, and there will be a bird just sing in the middle, right? A parrot or a myna or something like that, that bird cage. So think of the earth as a sphere suspended in the middle of the bird cage. What is the bird cage made of? He says stars. The stars are surrounding this cage, and the earth is a sphere in the middle of it. First, now you're asking, how can the earth be in the middle of something without falling? He says, think of it as a K-I-S Kanta Antaha. Kanta is magnet, Kandam. Antaha, between. Think of this picture in the bottom. Like a ball, if you balance one ball of iron between two magnets, it will float. Right? I'm sure you have played with like a pen or something when you had a magnet, your pen was made to dance on your desk, right? Try to put some magnetic object, it will dance on you, will keep doing that. So he's saying, this is what it looks like. Loha is iron. Loha iva vrutta is round, here it means ball. Okay? Think of it as that. Now, this is not Newton's G equal to, M1, M2, G, he's not doing that. But he's giving a metaphorical explanation to tell you how can the earth stand in the middle of space. Next. So, they not only came up with one concept of Bhugola, that earth is a sphere. Second, Khagola. Kha is the word for sky. Akasha, sky, etc. By the way, that word for sky, Kha, Akasha, etc. was also used for zero in something called Bhuta Samkhya. In Sanskrit, there is a way of numbering stuff. Besides giving the numbers like Eka, Dvi, Tri, Chatura, Pancha, Sapta, all those numbers, right? Nava and all that, Dasha, 1, 2, 3, 4, 10. You can also use objects for numbers. So, if we say moon, how many moons are there? Only one. So, moon means 1. Netra, eye means 2. Lochana, Netra, Akshi, all these means eye. So, that means 2. Okay, Rama means 3. Why 3 Ramas? Parashurama, Balarama, and Dasharatha Rama. So, 3 Ramas. Okay, Veda means 4 because there are 4 Vedas. Right? So, like the Pandava means 5. So, instead of using just numbers, you can also use familiar objects. Graha means 9. Navagraha. Right? So, like that, they were using certain words. Skanda means 6. Subramanya, Skanda, anything variation means 6. Even seasons, 6 seasons are there. Rutu. Those are called, that stood in for 6. Swara means 7. Sapta Swara. Sarigama Padani. So, they were using certain words, and for 0, they use sky. Sky represents 0. What does it represent? There's not actually anything there, but it is there. So, that is 0. So, beautiful word of using Ka and Akasha for 0. So, 3 spheres, Earth sphere, Ka sphere, the sky sphere, and the stellar sphere. That is the sphere of the stars far beyond. They understood the stars are very far away. Right? Because the planets are inside that sphere of the stars. So, that big sphere of space, they call the Bhagola. Bha is brightness, just Bhagola. It's just a word. Next, please. This is a painting in the Madurai Meenakshi temple. How many of you have seen it? 2 people. If you go to Madurai Meenakshi temple, you come out of the Chokkanada Shiva shrine, you come straight out. One side you go, you will see the 1,000-pillar mandapam with the museum now. That's the museum is there now. You come to the other side, there is a mandapa that everybody ignores. There is a 500-year-old painting of Maharaja Periya Krishnappa Nayakar. It even has a marker next to it. Next, please. And it has the Tamil word next to it saying this person drew it. There is now a flex banner with a modern update of this old painting. And this one says Kagolam, the stellar spheres. If you go close, you will see Jupiter, etc. and all that stuff. Okay, we'll see, Vakram movement of Vyadan, Velli, and all that stuff will be there. Okay, you can see it. That painting is there. So Kagolam, Bagolam, etc. They knew. Just giving this is not properly an astronomical this thing, but there's a 500-year-old painting. 1568, 100 years before East India Company came to Madras. Okay, next please. And 40 years, 100 years before Newton was born. We have a couple of stuff. Varahamihira then gives another explanation on why things, how can things stay on this spherical earth? First ask, if this platform is spherical, unless I'm a gymnast, I can't stand on it. And if I move sideways, I'll fall off it, right? Normally I should fall off it. But without gravity, how do you explain the spherical earth? He's giving one explanation. It's not the correct explanation, but it is a satisfactory explanation. There's a difference. Okay, he's again using a poetic metaphor. He is saying, Gaganam upayati shikishika, kshiptam api kshitim upayati guru kinchit. So suppose Gagan shiki shika. Shiki means the flame. Shika means lamp. Okay. If you take the flame of a lamp, you do Kartikeya lamp, right? Oil lamp, or take a candle or something like that. What happens? If you move it left and right, what will happen? The lamp will move, the flame will always point upwards. Right? Gaganam means sky. Akasham, Gaganam all means sky. Gaganam upaiti, the flame will always seek the sky, point out upwards. Whatever you do to a lamp, the flame will always try to go upwards. You can never force a flame to come downwards. Okay? Kshiti upaiti, Kshiti here means earth. And any heavy object, Guru means heavy, Kshiptam means tossed. If you take a heavy object, if I toss this, what will happen? It will come back down. Any heavy object will always come to earth. So he's saying a flame will always point up and any heavy object will always point down. If you ask why that is, it says that is the inherent nature of that object. The inherent nature of the flame is to go up. And so like that, all creatures, it's inherent nature to stick to earth with our feet downwards and our head upwards. If you are asking why are you walking on 2 feet instead of 2 hands? Right? It's the question you will ask. Why is a mango green? It's the nature of the mango to be green. Then you can do analysis with chromatic aberration or whatever, light, its reflection, absorption, pigmentation, chlorophyll, you can give all these names. But to get to that, you have to have fundamentals. So you can say the nature of the mango is to be green. The nature of the orange is to be orange. Right? The nature of sugar is to be sweet. So you give this the nature. That's what he's giving natural explanation. So like that, all people, all animals stand with their feet on the earth and head towards the sky. It's a metaphorical explanation, but it is a satisfactory explanation. Not necessarily an accepted explanation. It's just a satisfactory explanation. For the astronomers, it was acceptable. General public didn't care. Next, please. So, what is top and bottom? So, if the earth is like a sphere, what is top, what is bottom? He makes a joke. At this point, an astronomer actually makes a joke. Aryabhatta makes a very similar joke. He says, now remember they have redefined the North Pole to be Vadava, the Devaloka, Meru. So Devas are standing on top. South Pole is now Vadavamukha, Narakaloka. Asuras are standing on top. They are upside down, right? In relation to. So he's saying the Devas and the Asuras are standing on each other, are standing on the two worlds, the two corners of the world, and they think the others are beneath them. Devas think we are superior, you are at the bottom. See, he is using a status mindset to give a geographical explanation. They both think that they are superior and the others are inferior. He's completely leaving out men, but kind of mentions this thing. So he says, just like, and he gives another metaphorical example also. He says, if you stand at the edge of a lake, what happens? You are standing with the feet on the ground and your head upwards, but what is your reflection looking like? It has got upside down reflection. So its feet is there and the head is downwards. Right? And that is the nature of things. The reflection's nature is to be opposite of what the reality is. So like that, Devas are standing on top of the North Pole, Asuras are standing, and like this reflection is saying, he's giving a kind of a jocular explanation also. Next please. So what are the mathematical and astronomical concepts? Let's come to the structure, the core of this topic. I think I used up all this time just for this. Okay, next please. So, once you have a sphere, you have equator, meridian, then you start getting geometry and all that. You have new concepts or pudiya chittam, thought, idea, and if you have a bunch of siddhas and you put all these siddhas or ideas together, you call that a siddhanta, siddha anta, collection of finished thoughts. Siddhanta, philosophy or science. Right? This is what he's calling. The astronomical books are called so Surya Siddhanta, Pitamaha Siddhanta, Vashishta Siddhanta, etc. Aryabhatiya Siddhanta, Brahmasputa Siddhanta, and so on. Got it? Next, let us see what it actually looks like. So this developed to all of this which I already mentioned, and we look at some of these in a little more detail. Next, please. First, angular measurement. Right? You can get angles. You got 0 to 180 degrees now, 360 degrees. They had this idea of 360 degrees. Whether 360 degrees Indian, we don't know. I'm fairly sure it's not Greek because the Sumerians used it, and it's somewhat clear that the Greeks copied from the Sumerians. Whether we copied from the Greeks, the Sumerians, or invented it, that's not clear at all. It's quite possible that we copied it from the Sumerians or the Greeks who came from the Sumerians. It's quite possible that it did. In fact, scientists or historians of science are perfectly confident, 100 or 99%, 99.9% confident that we copied what is called the zodiac. You know, this Mesha, Rishabham, that Meenam, Patram. We are 100% sure that we copied it from the Sumerians. And the Greeks also copied from the Sumerians. Romans copied it from the Sumerians. That everybody is very clear of. 100 years ago, they didn't think that. They thought that the Greeks are the ones who invented it. But clearly, the Greeks copied it from the Sumerians because the Sumerian records are much older. Using this, there is no Greece there. The Sumerians are already recorded as zodiac. Okay, and we don't have zodiac in our Lagada's book, the old books, but we have using the Lagada, the zodiac in Surya Siddhanta, Aryabhatta, etc. They're using. So that means what? They've introduced the concept. Likely, most likely, they copied this from somewhere else. Okay. So these angles also they have copied from there, possibly copied from there, because the division of the angle is not 10, 10, 10, which is our decimal system, but 60, 60 is used. 360 is used for a sphere, 60 is used for each degree, and the degree is divided into 60 minutes and the minute is divided into 60 seconds. This is what you are studying today, right? 1 degree is 60 minutes, minute is 60 seconds. Now, second is measure of angle or time. Both, the word is used the same. In India, we used 5 measures, not 3. The angle was divided not into 3 measures, but 5 measures. 30 degrees, the cluster of 30 degrees is called a Rashi. If you divide a circle into 12 Rashis, each Rashi is 30 degrees, correct? If you divide 360 degrees into 12 clusters, each is 30 degrees. That is what a Rashi is. Mesha or Aries, 30 degrees. Rishabha or Taurus, 30 degrees. Gemini, whatever, 30 degrees, right? 30, 30, 12 30s are, you get that, okay? The degree was called Amsha or Bhaga. That is a Sanskrit word for it. The word degree was not used. The word is Amsha or Bhaga. Okay. For minute, the word used was Kala. Okay. Kala just means subdivision. Those of you know something about Iyengars know there is Vadakala, Tengala, Vadakalek, Tengale. Kala is division. So that Kala is just division. 64 Kalas are 64 arts. The arts come from 64 divisions of skills. Okay, painting is an art, dance is an art. There seems to be some relation to that. A division of the Kala is called a Vikala. The division of the Vikala is called Lipta, and this seems to have come from a Greek word. So there is some influence there. Some people think it comes from the word lepton, so it's not clear if it's 100% that's this thing. But we didn't use the 3-fold degree division, we used a 5-fold degree division. What is it? Instead of just saying 72 degrees, 8 minutes, 25 seconds, which is what the Greeks and the modern European system and today worldwide is used, we won't say 72 degrees, because 72 degrees is 2 times 30 degrees, 60 plus 12, so 2 Rashis plus 12 degrees. You understand? 2 Rashis plus 12 degrees, so 2 Rashis, 12 Amsha, that 8 is called Kala, no? Minute Kala, 8 Kala, 12, and then what is the next one? 25 Vikala, and then we had a further division called Lipta, 50 Lipta or something. Illa, degree is 360 undu. But 2 ஆச்சுனா அது டிகிரியா மட்டும் இல்லாம அந்த கவுண்ட்ல போய்டும். நம்ம மணிக்கணக்குல சொல்றோம்ல. You can say 72 minutes or you can say 1 hour and 12 minutes. அந்த மாதிரி. Right? 90 minutes, exam 90 minutes or 150 minutes னு சொல்லலாம். இல்ல 2 hour, 2.5 hours, 1.5 hours சொல்றோம். அந்த மாதிரி. Using that word. Okay, next please.
Siddhanta
talks about it. 60
is a kala.
60 kalas is a bhaga, 30 bhagas is a rashi, 12 rashis is a bhagana.
Another
The circle of stars.
Bhagavad.
The circle of
stars is
12 rashis is a bhagana. Next, please.
And the
notice Aryabhatta noticed
the similarity is very, very
useful. He says, look at how the geometry resembles
division.
12 rashis is like 12 masas. In fact, Surya has spent, so now we have a solar month. Earlier, we had what is called a lunar month. Month was what is considered the period from one Paurnami to Paurnami. Some people use Amavasa to Amavasa, but effectively comes to the same. When we use month by month, what happens to 12 months? You'll have a shortage because solar year is longer than the 12-month period. We think of 12 months as 30 days, but lunistellar calculation 29 and a half days தான் வரும். 15 வருஷம் போட்டீங்கன்னா என்ன ஆகும்? 354 days ஒரு 12 பௌர்ணமி போய்டும். 354 days you have a 11-day shortage. So what will happen? If you use a 354-day year with this Paurnami to Paurnami, within 5 years you will have 55-day shortage. 55 days is nearly 2 months. 2 months is a season. Suddenly, instead of spring, you are getting beginning of year in winter, or instead of winter, you are getting it in spring. The month will change for the beginning of the year. In the Vedic period itself, they realized this, and that's when they introduced the concept of Adhika Masa. They added 2 Adhika Masas every 5 years, and then adjusted the months and the year. The Adhika Masa will not have a name; it will just have the association. அதாவது பக்கத்துல வர மாசத்தோட பேர் வச்சுவாங்க. அதிக ஸ்ரவண மாசா, அதிக ஐப்பசி மாசம் மாதிரி பேர் வச்சுவாங்க. The 2 closest one, they are calculated. But you look at the division, 12 rashis is a circle, 12 masas is a year, 30 kalas is a rashi, 30 dinas is a masa, 60 vikalas is a kala, 60 nadis is a dina. India did not have 24 hours this thing. We had a day divided into 60 nadis or 30 muhurtas. Muhurtam is a division of the day. 2 nadis is 1 muhurta. We still use it for weddings and all the auspicious functions. Muhurtam, Nalla Muhurtam சொல்லுவோம். That simply means this period. நம்ம எக்ஸாக்ட் டைமுக்கு நம்ம யாரும் வர மாட்டாங்கன்னு தெரியும். அட்ஜஸ்ட் பண்ணி சொல்லிட்டு 10 நிமிஷம் லேட்டா வருவோம்னு தெரியும். ஸோ முகூர்த்தம்னா இந்த பீரியட்ல இருந்து இந்த பீரியடுக்குள்ள 9 மணில இருந்து 10 மணிக்குள்ள வந்துட்டா போறோம் அப்படின்னு பேர் வச்சிருந்தாங்க. Okay, that is the auspicious time. So அதான் நாடி is the double of that. 60 nadis or 30 muhurtas. 60 vinadis, subdivision of each nadi is 60 vinadis. And 60 vinadi, each vinadi is 60 Guru Akshara. Guru Akshara na nam நெடில் எழுத்துன்னு அர்த்தம். ஆ, இ, உ, கா, மா, சை, போ. ஸோ நெடில் எழுத்து சொல்றோம் இல்லையா? ஒரு இத்தனை குரு அக்ஷரா சொன்னீங்கன்னா 60 10 தெரியல. பட் ஓகே, எனிவே, ஸோ certain number of Guru Aksharas will be 1 vinadi. So calculation for that. மாத்திரை இப்படிலாம் சொல்லுவாங்கல்ல. Next please. So the angular measurement was useful because we use celestial magnitudes and longitudes and most of the applied mathematics. If you look at what Indian astronomy is, or even Ptolemy and all that, most of the thing is just calculating all this, when timing, what will happen, when this. Because sunrise, moonrise, all கஷ்டம் கிடையாது calculation. ஓரளவு guess பண்ணிடலாம். But planets movement, eclipse லாம் predict பண்ணணும்னா ellipse. And that is the bulk of the mathematics that they were doing. Okay? Calculating rising, setting, angle, position, conjunction, velocity. The word for velocity was gati. Gamana, not poharadu. Gati, not speed of which going. Gati. If you look at the problems in some of the books, Mahavirana of the Rigar, he wrote a book called Ganita Sara Sangraha. He will write, if a man takes 3 months and 1.5 days to go from Varanasi to Ujjain, walking, what will another man take to go from speed, going in a bullock cart at the speed take from? What problem is it? If a train goes from Delhi to Bombay at the speed of this thing, what will a train going from? And the problem is instead of Delhi, Bombay, he's saying Varanasi, Ujjain, some other name, Somnath, something like that. In the older times, he'll be using. And problems, instead of distance in kilometer, meter, speed, and all, he'll be giving Yojana, Krosha, all the older measurement times he'll be giving. Lot of problems will be like, what is this problem for? Why do you care how much time it takes a man for going from Varanasi to Ujjain? How does it relate to astronomy? Any guess? Position, exactly. Position of what? If Mars is in Rishabha Rashi, how many times, how many days or months or years or whatever it will take for Mars to go from Rishabha Rashi to Kanya Rashi, say, and in that period, if the moon is moving, when will the two come together? Right? When will Guru, Jupiter planet, will come to Maga Nakshatra to calculate Mahamahamma Kumbha Mela? Right? What is Sani Payarchi? Saturn moving from one Rasi to the next Rasi. How long does it take? Calculate. Which day does it happen? That's how all our festivals are calculated. Right? That's how all those things are, all auspicious things, that everything are calculated. They are using it for this. They are using the mathematics, algebra, geometry for this. Next, please. Next. So they had a very clear idea of what now we have a Earth. They could see the sun moving back and forth. So this is different process, right? The sun is moving back and forth in what is called Uttarayana and Dakshinayana. They knew it before, but they thought it was something else. Now with the spherical model, they know there is a line called the equator going around, right? And the sun is going from equator to a particular point in the latitude, stopping and going down south. What is the point in India? The most famous city on that latitude where the sun stops, which is Tropic of Cancer, we call it today. Right? Tropic of Cancer means Cancer is the constellation. But on Earth, what is that point? In India, what is that point? They had a very famous city called Ujjain. Ujjain was the northernmost point of the sun's traversal. So they call that line going from North Pole to South Pole, Meru to Vadavamukha via Ujjain. They said we'll use this as the prime meridian. Ujjain is a great center of learning. Varahamihira also lived there. Several scholars are studying. We'll call that the line. Next, please. And so, next, please. That point, Ujjain, the meridian going through Ujjain, we won't call Ujjain meridian. We'll just call it Ujjain. Everybody will understand. Astronomers know it means Ujjain. If I say Greenwich, you know what Greenwich means. It's a meridian. If I say cancer, you know I mean the constellation, not a disease. If a biologist, a medical person will think of disease. Physics person will think of the constellation. It's very clear, like that. So Ujjain, or they would say, Ujjain is fine, but for some calculations, you need the point where 0 degrees meets 0 degrees. Longitude equals 0 meets latitude 0. So from that point, all calculations you can make. That point was called Lanka. The astronomical Lanka is not Sri Lanka, which is east of India, but this Lanka, which is a little south, exactly south of the Ujjain meridian, slightly west of Lanka. Okay? But creatively, they call it Ravanapuri and something like that. Because the word Lanka is too associated with them, Ravana, so they'll call it Ravanapuri and something like that. And so they have a list of points on this meridian. This town, Kurukshetra is on Ujjain meridian here. What is this useful for? I'll tell a story. There's a person called Lee Gentle, 17th century astronomer, came from Europe. He went to Thailand, and in Thailand somebody was calculating some eclipse. He said, I'll do it with seashells. He had 4 seashells. He said, how can you calculate that? He's doing some number stuff. Right? He was doing. Nobody knew what he was doing. The Lee Gentle didn't know what he was doing. He's saying, I'm calculating this and calculating this, calculating this. And then he came up with a number. He says, this date, this time. And then he did a subtraction. You did everything, suddenly you're doing a subtraction. What are you doing? You know what he was doing? He calculated everything for the eclipse, for the Ujjain meridian, and then adjusted it for Thailand. Latitude correction, longitude correction. So he was doing some numbers. He didn't know astronomy. He was just told some methods to do something. Right? He was using some methods to calculate something. Then at the final point, he made a correction. That is a longitude correction. Lee Gentle understood it was a longitude correction. What is this longitude correction he's making? Why are you doing it for some place in India? Then they look at the astronomy books and all Indian astronomy books, all the default constants are given for Ujjain. They say when the sun rises in Ujjain or when it is in Lanka and all that. Next, please. In fact, Aryabhatta says when it is sunrise in Lanka, and he means this Lanka, not Sri Lanka. 0 degrees longitude, 0 degrees latitude. When the sun rises at Lanka, it is sunset in Siddhapura. What is Siddhapura? It is the exact diametric opposite point, the antipodal point on the sphere of the earth. This only happens if you have a spherical model of the earth. Flat earth model doesn't work like that. It works differently. Okay, when it is sunrise in Lanka, it is sunset in Siddhapura. Today it will be somewhere in America, right? American continent. Noon at Yavakoti. Where is this Yavakoti? Some people think it is the tip of Java. Java is pronounced as Java or Java. Java, Yavakoti. And midnight in Romakavishya. Romakavishya means Romakadesha, which is, to them, Roman Empire is pretty much all of Europe. Somewhere there. Okay, they may have had a better thing, but he says, so what does this understand? What does this explain? The spherical model of the earth, the understanding that the sun is going around, and at each longitude the time is different, and at exactly the 4 points 0, 90, 180 and 270, you will have quarter of a day difference. Is this clear from that? Is this clear from that? When it is sunrise in Lanka, it is sunset in Siddhapura, noon at Yavakoti and midnight at Romakavishya. The 4 quarters of the earth have different times. And that is what they did. The big astronomers, the brilliant astronomers like Aryabhatta, Brahmagupta, Bhaskara would give you all calculations for Ujjain or Lanka. And then what somebody else would do, come along and do adjusted small tables. Railway minister will put a timetable budget for whole railways. He doesn't care which train is going at what time. Okay, what will happen? He'll be delegating it to general manager, regional manager and all that. Regional manager will come up and say, this train comes from Madras to Bombay Grand Trunk, will leave at this time. Madras to Bombay Dadar will leave at this time. This thing, you figure it out. Local station master will have then some other thing, right? That local station master equivalent was what the Panchangam people did. Right? Panchangam in Kumbakonam, Panchangam in Kanchipuram, Kumbakonam's longitude is different, latitude is different from Kanchipuram. They will do different. Madurai will have a different longitude, latitude. Take the numbers that the Siddhanta makers did, do local calculation and give Panchangam for local things. This is the correct thing. What we are doing today is wrong. What you are doing today is fraud. We are taking one longitude and applying that to all of India. Right? We are using Gujarat and Assam as the same longitude or same time zone. Assam is east of Bangladesh. Bangladesh is half an hour ahead of us. But Assam, we have to go, it's using the Allahabad longitude. Right? Somewhere in Varanasi, Allahabad, that area longitude is using. The time is, we are using the wrong time. These people for 1000 years are not using the wrong time because to them it was very, very important for rituals to be the right longitude, right attitude, right time. Next. The significance of the Ujjain meridian, next please, is for 2000 years they used it as a standard meridian, not exactly 2000 years, I don't know exactly, but roughly, because I don't know when was the first used. It was taken as the standard in all these countries, Burma, Thailand, Java, Sumatra, you can see references. Their calendars are computed using Ujjain as 0 latitude, Lanka 0 latitude. There is something called Deshantara, literally longitude adjustment. Adjustment for country, Desha Antara. And different longitudes, Kashi, Kanchi, and the local Panchangams are computed based on some local karnas. There are some sort of computing for thousands of yugas and all that. They come with local tables and then they do that. Okay, next please. And Aryabhatta, understanding this and telling you that the eclipses are caused because of this thing, he is talking about the geometry of how to calculate an eclipse. And he is giving step-by-step procedure. What is the size of the sun? What is the size of the moon? What is the size of the earth? What is the velocity? Next, what is the length of the earth's shadow? Next please. What is the length of the earth's shadow? It is sun's distance into earth's diameter divided by sun's diameter minus earth's diameter. Don't worry about accuracy in understanding this. I'm just giving you a sample. We can study it in detail later. Next please. You see circles and triangles. You know how to do the math there. Right? So calculate that. That is the length of the earth's shadow is this formula. Next. Diameter of the earth's shadow. Now you calculate length of the earth's shadow. What will be the diameter of the earth's shadow? Next please. And so you give some formula for that. Okay, geometric formula. So you have spherical geometry, you can calculate that. Calculate the speed at which these things are moving in different orbits. When the earth, sun, moon, etc. will come alive, calculate the eclipse, solar eclipse, lunar eclipse. When will it come, when will it not come? If the moon is, this particular moon and this earth are in the same parallel moment, it will come. If it's not there on the new moon, it's not there on the sun new, it won't come. It's given exceptions and all that. Next please. So then gives you things like, what is the visibility angle for a planet? So right now visibility, Venus is visible in the west. If you go in the evening, you can see very bright Venus. But Venus is only be visible above a particular angle from the horizon. If it is closer to the sun past a particular angle, it won't be visible. It gives that angle. The moon will be visible only 12 degrees away from the sun. So, மூன்றாம் பிறை தான் தெரியும். அமாவாசை அன்னைக்கு தெரியாது, அடுத்த நாள் தெரியாது, மூன்றாம் பிறை தெரியும். Right? Venus is visible 9 degrees away from the sun. Jupiter, Mercury, Saturn and Mars are visible at 11, 13, 15 and 17 degrees from the sun. He's giving some formula, calculations. And all of the books are like full of tables like this and calculations like this and computations and how we can calculate eclipses and rising and setting and planet conjunction. When will these two come together? Next please. So he's giving and this is an exaggerated picture. I'm just giving you a demonstration. So if it is closer than that, if it is less than 12 degrees, Moon will not be visible. Less than 9 degrees, Venus will not be visible, and so on. Next, please. So the understanding of eclipses as spherical shadows comes from the model of the spherical Earth. You have to have a model of the spherical Earth. Then you have a model of longitude, latitude. Using geometry, you calculate the speed, variation, and etc. of all this. Then you come up with this prediction. We think everything rises in the east and sets in the west, right? Every day everything rises in the east and sets in the west. But do they rise in the east and set in the west? Or do they appear to rise in the east and appear to set in the west because of the rotation of the earth? What is the actual direction of the moon? If you look at the moon, it's not every day on a daily basis it seems to go from east to west. But actual direction of the moon is the opposite direction. It's going slowly from west to east. And so, the eclipse of the moon will always happen from one direction to the other. It will never happen that other direction. The shadow will always go from this side to that side. It will never come from that side because the moon is always going this way. Right? Moon is going from west to east. So, the shadow of the moon will come like this. Moon will go this way. Right? Very simple. Let me walk across the screen and you will see what I mean. If I go like this, I am blocking this. Right? The shadow is coming behind me. Based on the light, the shadow can only be in one direction. What if the thing itself is moving? The direction of the shadow, you can guess from that, right? Varahamihira goes one step forward. He says, you can see that it is not a snake that is swallowing. He's giving the Rahu Ketu. He says, but because the shadow is always concave, the snake mouth will be like this. Shadow is always convex. The shadow on the moon, let's say lunar eclipse, the shadow on the moon, what did it look like? It is a ball like this, the shadow goes like this. Because a sphere always has a convex shadow. Whereas a snake will have a concave shadow. If a snake is mouth open, it will have a concave shadow. Saying, oh look, it's always that. And when will have something always have a circular shadow because it's convex, circular shadow. Only if it's a sphere. Because if it is a coin and it adjusts back and forth, sometimes shadow will be a straight line or an angle or something like that. Only a sphere will always have a circular shadow. Gives a lot of explanations. Next please. I am trying to give too many concepts in very short a time. But I am trying to give you what is the consequences of spherical earth. That is this concept of celestial longitudes, latitudes and all. So, they also looked at the sun going around the zodiac. Right? Next please. So, sun seems to be in one constellation each month. It's moving slowly through one constellation. They can't see the sun in the constellation, but when you, in the dawn before the sun rises, you can see the last constellation. Then you know the next constellation is where the sun is. Right? You understand what I'm saying? Right? Suppose some fourth or sixth person or seventh person is there. Suppose I want to tell you, I can say this lady in the green saree or lady in the yellow saree or something. Or I can simply say, lady under the second ceiling fan. Gentleman against under the fourth ceiling fan. I can say like that, right? I can say like that as an address. That ceiling fan becomes your address, right? That is what it is. Aries, Taurus, etc. Mithuna, Rishabha, all of these, they are addresses of the sun, moon, etc. Reference points to where these celestial objects are moving. So the sun is moving from one constellation to another. Now you can take the 0 point in space. They have all taken the 0 point in space. Worldwide, they have taken it as the beginning of Aries, Mesha. That point as 0 point in space. Okay, the year always begins with Mesha Rasi in all cultures. Okay, not just Indian, Greek, zodiac, whatever. The Chinese are an exception because they use a different zodiac. They don't use the zodiac. They use a different zodiac. The animals are different. They have rat, monkey, snake, etc. which you don't have in the zodiac. Right? Their use is different. Okay. But what do you see? You can see that the sun is in a different constellation each month. So now you have a solar month. You don't have to have Purnami to Purnami. You can use the sun as a marker of the month. Next. Next, please. This line is called Meshadi, and this leads to a particular thing. Next, please. So you have a solar month. They kept the same name, Vaikasi, Adi, Ashada is Adi, etc. Bhadrapada, etc. All these names, Kartikai, Mrigashirsha is Margasirsha is Margari, we call it Tamil, right? Pausha is Taimasam, Taisha, Pausha, Saimasam, and so on. Maga is Masi, etc. Palguni is Panguni and all that. But look at how precisely they have calculated the length of the month. 30 days, 55 nadis, 32 vinadis, 2 liptas, 39 viliptas. That is the correct length of the month. By observation, they have said exactly at this point, it's moving from this Rashi to that Rashi. Each month is calculated like this. So you have months of 30 days, 31 days, 29 days, etc. And 30 days again. And not just days, Nadi, Vinadi, etc. That is why in your Panchangam you'll have all of these very complicated numbers. You have tables and tables of numbers. You're thinking, what are all these numbers for? This is what is given. Now, solar month is measured by the time the sun spends in one Rashi as opposed to Purnami into Purnami of lunar month. Okay, so that comes to a proper equivalent. Notice that the days are different in different constellations. This is what Kepler came up with. No? It doesn't spend equal times in equal parts of the sky. Varies based on length and on the elliptical orbit it goes. They understood this. Okay, they didn't understand. They understood it. They understood that the circle was not. They still thought of it as a circle because ellipse was a nightmare to handle. Circle is easier to handle. And they came up with another alternative mechanism. They came up with what's called epicycle. We will go to next. Come next, please. So today we call celestial latitude and celestial longitude the parallel lines to the longitudes and latitude in space. In astronomy, it's called declination and right ascension. Okay, celestial latitude is called declination. It's measured in degrees. And right ascension is celestial longitude, which is measured in hours and minutes. Because it rises up at 5 a.m., it sets up at 12 it's easier to express in hours and minutes. Next, please. Next, please. Let's keep this. This is a lot of text. I won't go into that. Next, please. So, they use something called epicycle or mandavrittam to calculate the action position. They know that if you calculate the planets, try to use exact circles, you are going to fail because it's moving at varying speeds. The sun is clearly moving at varying speeds. So the planets are also moving at varying speeds. How do you deal with it? We will have a circle that's called mean circle. That is, we calculate the orbital radius of the planet or diameter of the planet. So that circle should give you a proper circle. That we call Kakshya Vrittam. That is orbital circle. Then we'll come up with a second circle called Sputa Vrittam. Okay, the Kakshya Vrittam, and then we'll have the actual position of the planet. Go next, please. And the diagram will next. So the Earth at the center. This is the Kakshya Vrittam or orbital circle of any planet. Next, please. This is Meshadi at the line taking to. If you take, remember this is a moving line, but take Meshadi as the zero line. Next, please. Then the planet is at any point where it is it. Somewhere on the planet 365 days you can calculate where it is because simply using arithmetic displacement you can say where it is, right? If it's on a proper circle. Next, please. But it is not going to be on that circle because it's moving at varying speeds. So I will use a second circle called a mandavrittam or an epicycle to calculate it. But so it will be somewhere on that circle. Where will it be? Next, please. It will be, next, please. If you take the apogee, that is the apogee of the planet, which you call Mandocha, if you calculate that, and astronomers calculated it, Aryabhatta, Brahmagupta calculated, tell you what this number is. Then you draw the parallel line to the Mandocha from the mean planet position to this epicycle, Mandavrittam cycle, and wherever that planet in that circle is there, that is where your actual planet will be. Right? Avoiding the ellipse, understanding that the planets are moving at different speeds and giving you a way to calculate the position using circular geometry. Right? And observations. You have a Meshadi, you have a Mandocha, which will different because each planet will have its own different apogee, perigee you are studying. You have a basic concept, you don't have to be exact. Okay? Let the astronomers deal with it. But you understand what we're trying to say. All of this they had. This is what the entire books are about. Astronomy books are about. We get no exposure to any of this. Nobody does. It's completely criminal what our education system is. Next. Mars, Jupiter and Saturn make longer orbits. So they understood something called Vakram. What is Vakram? You know that Earth is on one orbit. Mars and Jupiter, Mercury and Venus are inside, but Mars, Jupiter, and Saturn are outside our orbits. So imagine if you go in a train, right? Suppose you're traveling in a local train from beach to Tambaram, right? And express train, Thuthukudi, Pearl City Express or Vaigai Express or something overtakes you. What will happen? At some point, it will go faster than you. You will have a slight illusion of the trio train going backwards. Have you ever had that experience? You're moving forward, something goes faster. Especially if you wake up, you suddenly feel, am I going backwards? No, your train is going, this just the other thing is going faster. You have a relative movement of backward movement perception. That is called Vakragati in. Why? Because when the Earth catches up to the Mars orbit, every planet seems to go this way, right? East to west. They all seem to be going in one particular orbital direction. But there are times, instead of going past us, some planets seem to be moving backwards every day. You can see only some position. And every day, why is it going backwards? In the background of the stars, why is it seem to be going backwards? That is called Vakragati or retrograde motion. If you don't understand what it is, because I can't explain it in a very brief thing, go to YouTube. There are fantastic videos of explaining retrograde motion. Okay? That retrograde motion that we only study in English is called Vakragati. And this is something that very, very clearly is also calculated and explained in Indian mathematics. Next. And this all happens because of the consequence of, that's what it is. Okay, skip this picture. It's too much. So, next. Then, because of this, what happened? Earlier, Tithi was considered, moonrise to moonrise was considered Tithi. Sunrise to sunrise is called Dinam, daily day, solar day. Moonrise to moonrise is called lunar day. Moonrise varies daily. Okay. Now they said, no. Let's define the moonrise instead of moonrise to moonrise, which is arbitrary. Even sunrise to sunrise is a day is a bad count. Why? Because sunrise varies based on the season. Right? Some summer months the sunrise comes earlier, winter months sunrise comes later. So the correct position is not to calculate the day from sunrise to sunrise. Ideally, you should calculate from midday to midday or midnight to midnight. Midday to midday, the sun is very hot. You can't stare at the sun and this thing. Midnight to midnight is much easier. You take the central point between dusk and dawn. Midnight is easier to calculate using the sophisticated maths and astronomy they had. And that is what Aryabhatta introduced. Not zero. He called it Ardharatri or Ardharatri Paksham. Not Suryodaya calculation, but midnight is the start of the day. And he got criticized for it. But eventually, over a few centuries, first time people they rejected. Much later only they accepted. Ardharatri, worldwide you are using midnight as the start of the day. That is Aryabhatta's proposal. He is using that. They also use the diffraction of Tithi as 12 degrees variation from sun and moon. So moon is doing 360 degrees, sun is moving 360. Every time the gap between sun and moon is 12 degrees, within 12 degrees it's the same Tithi. If it goes past 12 degrees, it will be next Tithi. So Panchami is in one Tithi. When does it become Shashti? When the 12 degree gap between sun and moon becomes the 13th degree, then we'll call that Shashti. So the degree, angular definition of a Tithi came in. Angular definition of Nakshatram also came in. Next. So I think we'll stop with that. Nakshatram is redefined as something similar. Okay, next please. I'll just overwhelming you at that. And the Panchangam, suddenly we have a Panchangam. Before this we didn't have Panchangam. Why? Because zodiac was not there. Weekday is not there. Weekday and zodiac are introductions in Indian astronomy that did not exist before the Siddhantas. The Vedic period doesn't happen. So that means some new thing has been added. Okay, new thing has been added. Just like you added new planets, Neptune, Uranus, Pluto and all that. See, we make fun of astrologers, but a lot of the horoscopes suddenly started adding Neptune and Uranus also. And when Pluto became demoted by the astronomers, they were very, very keen. Should Pluto be taken or not? You may not accept it, but they are very interested in this particular thing. They are taking very authority as a particular authority. So you are taking in something, you are dropping something, right? You can take a planet in and drop a planet out in astronomy. So they are doing that in the calendar also. They are adding Vara, Karana, Tithi Nakshatra has always been there from the Vedic period. They added Vara, and Karana is something that is used in astrology. Astrology also is there only from the Surya Siddhanta and onwards. The earliest the things are. And something called Yoga. And these 5 elements are what is called the Pancha Angam or Panchangam. So the calendars also change because of this spherical model. Remember, my point, my thesis here is that the spherical understanding that the earth is a sphere changed so much of astronomy. Okay, what did it change? It started introducing equators, latitudes and longitudes. You created a spherical model of calculation of eclipses, understanding of celestial longitudes, etc. You have suddenly understand that this is a solar month. You can calculate the solar month. You started angular measurements with Nadi, Vinadi, etc. Right? You're doing eclipse calculation. You're introducing the entire Panchangam, your calendar based concept is changing. Okay, next. The tables of astronomical data are there. Next, please. Lots of tables are there. And last but not least important is something called the sign. Today, sign we thought of as, I can finish in about 2 minutes. I hope not too far past time. Okay, I'll finish in 2 minutes. Sign is what we take. What is sign today? What is the definition of sign? Opposite by? Who came up with this? Newton, Archimedes, Euclid? Nobody knows. I'll tell you one thumb rule. If an equation has a name, it's European. If an equation is anonymous, it is probably Indian. Okay. You will wear what shirt will you wear? Peter England? You will wear Peter England, Van Heusen, right? Calvin Klein. Where are all these? They are made in Tirupur. If Parvati and Lakshmi Pati made the shirt, you won't buy. If Peter Heusen, you buy. What? It's made in Tirupur only. Avinashalingam Mudaliyar or Chettiar has a plant, cotton plant. Some Lakshmi, Parvati, Uma, Ravi, somebody, they're all making this. But you want to call it Peter England. And you want to wear this shirt. Same thing. If an equation has a European name, Newton's law, Archimedes, Pythagoras, okay. Brahmagupta, no Brahmagupta, no Bhaskara, none of them. Okay, so let's go. So it's opposite by hypotenuse, right? What is the sum of the angles of a triangle? So can a sine be more than 180 degrees? Can you calculate sine of 185? With the triangle, can it be 180 degrees, more than 90 degrees? So opposite by hypotenuse means at least one angle must be 90 degrees. So there cannot be any sine of any angle above 90 degrees. But we are using a sine wave 0 to 90 to back to 180 to 270 to 360 and back to 540. You can put any number. Right? How did this happen? If sine comes from a triangle, you should not have any angle more than 90 degrees. Next. We use sine because it's very useful. Right? Any triangle you take, the opposite to hypotenuse will be always the same for that angle. Right? If it's 30 degrees, you can have a small triangle the size of this table, or you can have a gigantic triangle from Earth to solar system orbit, right? Jupiter's orbit, Saturn's orbit, Milky Way galaxy. Take it. Who's stopping you? Make a triangle between Milky Way galaxy, Andromeda galaxy, and some other galaxy. Triangle. Opposite by hypotenuse. If you ignore relativity and time dilation and angle dilation, same thing. Right? Any size of the triangle, you're getting it. But you're confined to triangles. Whereas the sine is not confined to triangles. The sine was not discovered as a ratio of triangles. It was discovered as a measure of the circles. Next. That is the Indian definition. Next, please. Next, please. This is why the sine is useful. Next. Sine is very useful because of, next, please. Height calculation, distance calculation. We know two sides on one angle or one side on one angle. The third side is easy to calculate. Next. So they were using it to calculate all of this. Next. Especially astronomical stuff. If you look at latitude and longitude, you use sine, you can calculate a lot of things without dealing with all the actual distances. You don't have to need absolute measures. Approximate proportional measure is right, you will get the same thing. Right? Whether it is 20 million miles and 15 million miles or 20 kilometers and 15 kilometers, you will get the same thing if you use the sine. Next. So it's very useful in this. Next. You look at the circle called Vritta, and you look at the chord of the circle and the arc is called chapa or bow. Chapa means bow or dhanush, will, right? Sanskrit word is chapa or dhanush. Chapa is more popularly used in mathematics. And the line chord connecting them is called bowstring. It's a bowstring, right? If you use a bow, the bowstring is called the bowstring. The word for bowstring is ja in Sanskrit. That's the word. The Sanskrit word for bowstring is ja. From this ja, half the ja, the cord is the measure of the arc, correct? The arc will always be proportional to that cord. The length of that arc will always be proportional to the length of that cord. Now you take this and make a triangle, right angle triangle, where take a half a cord, you draw a radius here, right? EB is a radius, ES is a radius, correct? E is the center of the circle. Any line from the center to the edge of the arc of a circle will be radius. ES is a radius, EB is a radius. So under the A to S is a particular point that we call a ja. Ardha ja, but they called it ja. Ardha ja means half ja, but they called it ja for convenience. Next. So use that, and that is the measure. So if you next please. So the Indian triangle, the sine is the measure of the arc, but arc is hard to measure, so they measured the chord. And what is the chord? The size of the chord, length of the chord. If you take the length of the chord and divide it by the hypotenuse there, which is the radius. Could you go to the previous slide for 1 second? If you look at the hypotenuse, so if you change the chord at any point, right, the hypotenuse will change the same, the denominator will change the same. The Indians didn't consider the denominator at all. They only considered the chord. Next. And then go to next also. Next. It's very important. Next. Skip this. Next. So if you look at this triangle, if you look at the chord, in each one you look at the green part. Green part gives you the chord. The arc, it gives you the measure of the arc. So if you look at the radius, that is the red part, either it's 30, 45, 80, whatever, the hypotenuse is always the radius. We can ignore it. The measure is only this. That measure they calculated. And how do you calculate that? Aryabhatta gives a way, but it was much used and much before. Today, we study a same table is 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The Indians didn't use that. They said 24 signs. And they calculated 60. From that they calculated 30. From that they calculated 15. From that 7.5, which is half of that, and 3 3/4. 3 3/4 was your first sign, 7.5 was your second sign, 10 1/4 was the third, 15 is the fourth sign. Like that, 24 signs up to 90 degrees. Understood? Next. So those 24 signs you can calculate 3 3/4 degrees, 7.5, 10 1/4, 15, and so on. Okay, next. So that ja, if you take a unit radius of 34, 38, why is 34, 38? If you use 34, 38, then the circumference circle multiplied by 3.1416, you will get 21,600. 21,600 is 360 into 60. You have 360 degrees. You have minutes, kala. You can divide the circumference of the circle into small segments that are all 1 minute, 1 degree, 1 minute long. Okay. So then you can measure the length of the ardha ja. Imagine a circle, and you can calculate with this thing. So we can calculate with this. Next, please. I'm jumping here because of delay of time. It's a complicated. It's a 45-minute lecture by itself. Okay. Next. But we should be studying this in school. This should be taught in every school. I shouldn't be teaching it to a faculty program or something here. Okay. Aryabhatta says, I'll explain this with the picture. Next. He says, if you draw an equilateral hexagon, the side of the hexagon will always be equal to the radius of the circle. Side of the hexagon will be equal to the radius of the circle. This is a fantastic observation he's come up with. Next. So if you draw an equilateral triangle based on this one side of the radius, right? So you do 2 radius. Now these are the sides of that. This will be equivalent to the radius, right? So these 3 sides are forming an equilateral triangle. Right? It's an equilateral triangle. If you have an equilateral triangle, I know this is 34, 38. This is 17, 29, half of that. This is also 34, 38. You have a right angle triangle. Hypotenuse squared minus base squared will give you this squared. Then you can calculate that one number. Next. If you calculate that number, which they already had, by the way, that is called Baudhayana theorem, long before Pythagoras. You can calculate sine of 60 as 2977 units. That is the measure of the ja. From sine 60, he knows how to extrapolate to sine 30, then from sine 30 to 15 and so on. He calculates. The entire table is generated. You have 34 sines. The sign is coming as the measure of the circle, and he is using algebraic measure of the Pythagoras theorem to calculate this. Understand? And he is using only that, not opposite by hypotenuse, only opposite. So in Indian sign is called radial sign because it's effectively multiplied by the radius. Because the hypotenuse is the radius here. Understood? Okay, if you don't understand, it's okay. If you go through it 2 more times, you'll figure it out. It's not very complicated. Next. So this ja went from Sanskrit to Arabic. It became ja, which is a mispronunciation. The ja, which is a mispronunciation, became jobi. JB, pocket. If you take ja and they pronounce it as job, jab, JB, ja doesn't have meaning in Arabic, but jab, JB doesn't have meaning. It means pocket. That the America, the Italians copied. They translated pouch or pocket to sinus, which is also a pouch. Your nose is a pocket because it's called sinus because it's a pocket shaped thing, right? Pouch or pocket shaped thing that became sinus. The English, of course, like Julius became July and Augustus became August. The us went away, so it became sign. And now we are taking this job, sinus, sign, and learning it as sign without knowing the original word that came from Sanskrit, like Bijaganita and algebra. So this is what happened. Sanskrit ja came back to India as English sign. Next. So I hope I have kind of given you an insight into what the historical aspects are. And sign came from the spherical geometry. You understand why that is, right? Because you take the orbits, you take these things you want to calculate. So multiple aspects are there. So let's not obsess only with the telescope. Let's look at other aspects of the history of science, astronomy, etc. to understand what it is that is important, what it is that we should understand. Thank you very much. If you have any questions, I'll be happy to answer them.
Or you can interact later during lunch. Lunch kirunga.
Thank you.